Hello, and welcome to this GCSE Physics exam preparation video on atomic structure. This is the nucleus of a carbon atom. It is 1/10,000th the size of a complete atom, but has the majority of the mass in the atom because it contains the protons and the neutrons. This is a neutron. It has a relative mass of 1, but a relative charge of 0. This is a proton. It has a relative mass of 1 and a relative charge of +1. Because it's a carbon nucleus, there are 6 protons. Here we have an atom. The difference between an atom and a nucleus is that the atom has electrons that move around the atom in energy levels. This symbol represents an electron. Electrons have very small masses and charges of -1. Atoms are also bigger, with a radius of 1 × 10 to the -10 metres. The number of electrons is the same as the number of protons. This makes the atom electrically neutral, positives balanced by negatives, so it has no charge. Electrons can sometimes move up an energy level. This happens when they absorb the correct amount of energy from an electromagnetic wave. The electron will eventually drop down again, and as it does so, it releases energy in the form of an electromagnetic wave. Atoms can be represented like this. Here you have the element symbol. In this example, it is sodium. This is the mass number, the total number of protons and neutrons. And this number is the atomic number. This is the number of protons. So sodium has 11 protons, shown by the atomic number. It has 12 neutrons, as 23 minus the 11 protons gives you the number of neutrons. And it has 11 electrons, which it must have because the electrons are negative and they balance out the positive charge on the 11 protons. Isotopes are elements that have the same number of protons but different numbers of neutrons. They have different masses. Here we've got carbon-12 and carbon-14. Carbon-12 has 6 protons, 6 neutrons because 6 from 12 is 6, and 6 electrons because again the negative charge on the electrons is balancing out the positive charge on the protons. Carbon-14 also has 6 protons because it's carbon, and carbon always has 6 protons. It has 8 neutrons, it's slightly heavier than carbon-12, and again it has 6 electrons because the electron charge must balance out the proton charge. Ionization is when you produce an ion, which is a charged particle, from an atom which is uncharged. An atom has the same number of protons and electrons, so has the same number of positives and negatives. This means an atom has no charge, it's electrically neutral. However, if an electron is removed because it's been given enough energy, the balance of positives and negatives is altered. There are less negatives and more positives. A positively charged particle has been created, and we call this an ion. This is common content with GCSE chemistry. The ancient Greeks thought atoms were tiny spheres that could not be divided. And this didn't really change much until J.J. Thomson discovered the electron in 1897, and this led to the plum pudding model in 1904. The plum pudding model is where there are electrons randomly placed in a positively charged cloud. The positive balances out the negative because the atom has an overall 0 charge. Rutherford in 1909 did an alpha scattering experiment where alpha particles were fired at thin gold foil. He was trying to confirm that the plum pudding model was in fact true. Unfortunately, his results led to the conclusion that the plum pudding model could not be the case, and in 1911 he announced his new model, the nuclear model. This is where we had a central nucleus and it's charged positively, and this is what was causing large deflections of the alpha particles, which were not expected if the plum pudding model were in fact true. The nuclear model was then adapted by Niels Bohr in 1913. He added electron orbits at specific distances. Bohr's calculations agreed with the experimental evidence, and that's where he had this idea. Experiments then gave the idea that positive charge could be divided into whole numbers of small particles, which is where we get the protons. And then finally, in 1932, James Chadwick, he provided evidence to show the existence of the neutron in the nucleus. This is about 20 years after the accepted existence of the neutron. Decay is when an unstable nucleus gives out radiation to become more stable. This process happens at random. Nothing can speed it up, slow it down, or stop it. These are the types of nuclear decay that you need to know about. Alpha decay. 2 protons and 2 neutrons are ejected from the nucleus. An alpha particle is also known as a helium nucleus. Beta decay. A neutron turns into a proton and an electron. The electron is ejected from the nucleus, and that is what a beta particle is. The proton is kept. Gamma decay. This is high-frequency electromagnetic energy waves given out from the nucleus. And neutron decay. This is where a neutron is given out from the nucleus. The above are properties of nuclear radiation that you need to know about. You will need to apply this knowledge to select the best type of radiation for a given task. For example, a smoke detector in a house needs to be a type of radiation that will be blocked by smoke particles, something that's not very penetrating so that the radiation will be kept within the smoke alarm, and alpha radiation fits both of these needs. These equations show the starting unstable isotope, the type of decay, and the element that the unstable isotope becomes. This is radon, which decays by alpha decay. When something decays by alpha decay, it gives out an alpha particle, which is 2 protons and 2 neutrons. This is the same as a helium nucleus. The atomic number of the helium nucleus is 2 because of the 2 protons, and the mass number is 4 because 2 protons and 2 neutrons are released together in alpha decay. As radon decays and gives out 2 protons and 2 neutrons, its atomic number goes down by 2 to 84. As it gives out 4 particles, its mass number goes down by 4 to 215. This is an isotope of polonium. Carbon decays by beta decay. In beta decay, a neutron decays into a proton and an electron. The proton is kept in the nucleus and the electron is given out. This is a beta particle. This is the symbol for a beta particle. As an electron has very little mass, its mass number is 0. Its atomic number is -1, as it's an electron, not a proton, so can't have a proton number. And -1 is useful for making the numbers balance. You'll see this later. As an extra proton is created in beta decay, the atomic number goes up by 1. The mass number stays the same because the neutron decayed into a proton, so overall the mass has not changed. This gives us an atomic number of 7 and a mass number of 14, which is an isotope of nitrogen. You can also look at the numbers in each line. Everything to the left of the arrow should add up to everything on the right of the arrow. So at the top here we have radon, which is 219, and then on the other side it's decayed into polonium, 215, and a helium nucleus has been given out, which is 4, and 215 plus 4 gives us 219. On the bottom row, we've got 86 as the atomic number for radon, and then for polonium we've got 84, and helium is 2, so 84 plus 2 gives us 86, so we know that our numbers are correct. The same goes for beta decay. We have 14 as our mass number on the left-hand side for carbon, and if we look at the right-hand side, we've got 14 for nitrogen and 0 for the electron, and so that gives us 14. If we look at the atomic numbers, carbon has an atomic number of 6, nitrogen has an atomic number of 7, and our electron, its atomic number is -1. 7 plus -1 is 6, so that balances as well. Gamma decay is when electromagnetic energy is released from the nucleus, so the atomic number and the mass number do not change. This means the nuclear mass and the charge of the particle also remain the same.